So good morning everybody, myself Acharya Vishvendra, and in NCERT line-to-line discussion we are discussing chapter number 14, which is semiconductor electronics. So let's start with question number 72 here. So it says that in the above question different energy bands overlaps. So the overlapping takes place in region C. Next is in region C energy gap exists between upper and since they overlap, so there do not exist any difference between upper and lower energy state. So second will be correct. Next is in the above question in region D, in conduction band there are. So initially there are no electrons in the conduction band as all the electrons are valence, and we assume that all the bonds are intact and are not broken. So there are no conduction electrons. So conduction band is empty, hence one is correct. Whereas in valence band there are 4 n electrons, we assume that all the bonds are intact. So all the electrons corresponding to the n atoms are bounded to their parent nuclei. So second is correct over here. Next is valence band. So valence band is completely filled. The lowest energy level in conduction band, this is called EC, and the highest energy level in valence band is called EV. Next is in the above question, infinite energy states exist above EC and below EV. So there exist obviously below EV and above EC. One is correct over here, as infinite states exist above EC and below EV. Next is the gap between top of valence band and bottom of conduction band. This is called the energy gap or the energy band gap. So both are correct. So 4 will be correct over here. Next is energy gap maybe. So all are possible. It's 4. Next is at 0 Kelvin, all electrons in a semiconductor, so they are in the valence band. So a semiconductor behaves as a insulator at 0 Kelvin. It's a very important concept over here. Next is a substance is called metal when conduction band is partially filled and valence band is partially empty. They overlap, so both are possible. So when there exists a situation in which conduction band is partially filled or both band overlap, so this corresponds to a metal. Next is when the valence band is partially empty, then electron from lower level can move to the higher level and electrons from higher level can move to the lower level. So when the valence band is partially empty, then electrons from lower level can move to the higher level. First is correct. Actually the conduction in valence band is concerned with the movement of holes. So suppose this is the valence band, this is the topmost level of valence band, and suppose that a particular electron is here. So if the states are empty, then this electron can move to the higher levels, and due to this movement there is a conduction possible, and we can make use of the energy during the process of this transition. So it corresponds to the shifting of hole from one of the atom to another. So electrons from the lower level can move to the higher level. One is correct over here. Next is for metals energy gap is it's like 0 electron volt. Next is for insulators energy gap is it's very high, greater than 3 electron volt. Next is for semiconductors energy gap is, so this is less than 3 electron volt, lies between 0 to 3. Next is the structure of germanium and silicon are called gold like structure or diamond like structure. So obviously they are bounded by bonds, so they are called diamond like structures because of similarity with the structure of diamond, which is basically carbon. So carbon is in fact the first element of this group, carbon, silicon, germanium, so it's called the diamond like structure. Next is number of valence electrons in silicon and germanium, so obviously these are 4. Next is in its crystalline structure, every silicon or germanium atom tends to share one of its valence electrons It is sharing one of its valence electrons, making a total of 4 covalent bonds so as to complete the octet. Next is in the above question, is silicon atom only share electron, take share of electron. So it's partial, as in covalent bond, it's partial sharing of electrons. So both will be correct over here. So in its crystalline structure, silicon atom forms valence bond, covalent bond. Actually, both of these are same thing. So 4 will be correct over here. Next is in the above question, the two shared electrons can be assumed to remain fixed or shuttle back and forth. So it's actually shuttle back and forth between the associated atoms. Can be assumed. Next is lattice spacing. Lattice spacing for carbon in its crystal structure is. So the lattice spacing in carbon is about 3.56 angstroms, whereas for silicon it's 5.43 angstrom, and for germanium it's 5.66 angstrom. Next is in crystal structure, all bonds are intact, obviously at low temperature, because at high temperature the bonds can be broken because of the energy given to the electrons. So all bonds are intact at low temperature, obviously. Let's move back to the next question. It is that on increasing temperature, bonds in a crystal lattice, they may break. The best option is may break away, so third is correct over here. Next is free electron in a silicon crystal after bonds break contribute to conduction. Obviously they will contribute to conduction as it is free to move. Next is effective charge on a hole is, effective charge is positive. Hole is a positively charged particle, negatively charged particle, neutral particle, or a vacancy. So hole is basically a vacancy. So 4 is correct. Next is hole behaves as, it behaves as apparent free particle with effective positive charge. So third is correct over here. Next is in intrinsic semiconductor. Obviously number of electrons, holes and conductors are same, intrinsic conductors. So first is correct. Next is in semiconductors, only electrons move, only holes move, both moves. Next is holes moves due to the movement of, obviously the movement of bonding electrons. So holes are due to the movement of bonding electrons. Next is under action of external voltage, holes moves from, so they are apparent positive charge, so they moves from positive to negative side. So first is correct over here. Next is under the action of external voltage, direction of hole current and electron current, obviously these are in opposite directions. So here both currents add up, and as the moment of